Alright, this is Trig Unit 2, Topic 4 on translating trig graphs. Hopefully you have a basic understanding of the trig functions already. Again, we talked about sine of x, cosine of x, and tangent of x, and we talked about the input. The x value for any one of these is an angle, and we prefer that angle to be in radians. And the output for sine is the y-coordinate from the unit circle. The output of cosine is the x-coordinate from the unit circle, and the output for tangent is the relation or the ratio, of y divided by x. So we talked about the 5 critical points for any one of these graphs. So remember, sine at 0 radians starts at 0. And as we go to pi over 2 radians, we reach our max of 1. And as we go around to pi radians, we're back to 0. And at 3 pi over 2 radians, we're back down all the way to our minute, negative 1. And at 2 pi, a full trip around the circle, we're back to 0. So that is why sine has this basic graph that goes up to 1, to 0, to negative 1, and back. And then that pattern just keeps repeating, obviously. Now, cosine is a little bit different. At 0 radians, cosine starts at a value of 1. And at pi over 2, it reaches down to 0. At pi, it reaches its min at negative 1. And at 3 pi over 2, it's down all the way to 0. Or not all the way, I guess negative 1 would be all the way down to 0. And at 2 pi, it's back to its max of 1. So cosine behaves a little bit different than sine. It starts up here at 1, goes down to 0, down to negative 1, back to 0, back to 1. Make sure that you make that a nice smooth curve and you don't make it this sharp, jagged curve, okay? In tangent, at 0, tangent is the ratio, so you got to remember it's the ratio of the y divided by the x, so that would be 0. So it has that point 0, 0. At pi over 2, it actually does not exist. It doesn't make sense because it's 1 divided by 0. So remember, that's going to be a vertical asymptote. Okay, at pi, it's back to 0. At 3 pi over 2, it once again does not exist. So again, that's another asymptote. And at 2 pi, it's back to 0. So it's kind of a weird graph. You just have to understand that at 0, we're at 0 here. At pi over 2, we got an asymptote. Then we're back at 0. Then we got another asymptote. Then we're back at 0. So it's also kind of good if you think of it the other way as well. At negative pi over 2, there's going to be another asymptote. So it's this constant wave here, okay? That's what tangent looks like, and hopefully that makes sense. Remember, tangent is allowed to go up. There's no min or max for tangent. It goes up or down as low as it wants. It could be any value. It's not stuck between negative 1 and 1 like cosine and sine. And also understand that at pi over 4, so halfway from 0 to pi over 2, pi over 4, remember it's at 1. So that's why it's causing that curve. And at negative pi over 4, it's down at negative 1. So it's making this curve in between the asymptotes. You got these asymptotes every pi over 2, and then it's this snake almost like graph in between them. So what we want to talk about in this particular section is translating these trig graphs. So sliding them. Remember, translate means to slide or shift. Okay, the next topic is going to be stretching. So we're not talking about stretching, we're talking about just shifting. So the first type of shift is a vertical shift, vertical meaning up or down, and that's represented by a value that's added or subtracted out in front of the sine or the cosine. So this is a number out in front. So I can give you an example like 2 plus sine of x, or 3 plus cosine of x, okay? So these are vertical shifts. Now, we could put it on the back. So another way of saying that would be sine of x plus 2. But we don't want to, the reason why we normally put it in the front is because we don't want to confuse people and think that this is sine of x plus 2. It's sine of x, take a breath, plus 2. So sometimes we really prefer to put that value in front. We could also have a negative, like it could be negative 4 plus cosine of x. And these simply shift the entire graph up or down. So obviously it's a positive 2, the entire graph is going to go up 2. If it's a positive 3, the entire graph is going to go up 3. If it's a negative 4, the entire graph's going to go down 4, and so forth. So negative means down, positive means up. Makes a lot of sense. It's the actual value itself that's going to tell you if you're going up or down. So a couple comments here on vertical translations. Only the y value is affected. Okay, because all we're doing is going up or down. So that only affects the y value. So the x values are not affected at all. And we're not stretching, we're shifting up and down. Okay, so I got a couple pictures here to have this kind of make sense. So this first one here, I know it might be kind of small, so I'll write down what it is. This is y equals sine of x plus 2. Or remember, we would prefer to write that as y equals 2 plus sine of x. Same thing. Now notice here in the middle here is the original sine graph right here that's going from 0 to 1 to 0 to negative 1 to 0. Notice that it's kind of fuzzy, I'm sure, when you see it on the screen, but this is obviously pi over 2, pi, 3 pi over 2, 2 pi, and then it repeats itself. Well, if we take the whole graph and shift it up, the whole thing gets moved up. So this point at 0 gets moved up to 2. This point at 1 gets moved up to 3. This point of 0 gets moved up to 2. Negative 1 gets moved up to 1 because it's going up 2. And 0 gets moved up to 2. So now the graph, it's the same graph, it's just shifted up. The whole thing is like slid or shifted, or we call it translated up. Another way of looking at it is if you think about that sine and cosine as well, it like wraps itself around this x-axis, the x-axis, or which is the line y equals 0, it wraps itself around it, so it's going above it to 1, down below it to negative 1, above it to 1, down below it to negative 1. So what we're thinking about is when we shift, we're taking that line that's wrapping itself around and we're shifting that line up. So that line that was at y equals 0 is getting shifted up to 2. So now we're wrapping ourselves around 2. Hence making this graph that's going up and down and up. Okay, it's kind of a bad drawing. It doesn't really look very good. But this drawing down here, right here, is supposed to show that. And this is actually, this is, I don't know why I changed it. But anyway, this is y equals 3 plus sine of x. Okay, so we shifted it up to 3. So here was the original value 0, 0, and here's that line that we were snaking around, or we were wrapping ourselves around, and we shifted it up 3 units. So now my max that was at 1 is now up to 4. My min that was down here at negative 1 shifts up to 3 and is now at 2. So we have that sine function in here snaking around. So the whole graph gets moved up. So again, it's pretty easy to understand that. Again, it's the value that's out in front. It could be in the back as well. Just be careful. Don't assume, if I wanted this to be sine of x plus 2, I would put parentheses like that. And we're about to learn that that means something completely different. So it's not that. It's the 2 is on the outside. It's separate from the sine. Okay, so the last thing I kind of want to go over real quick is those critical values. Okay, what's happening to those critical values? So let's talk about this y equals sine of x plus 2. So remember, at 0, I was starting at 0, but now that got shifted, the y's went up 2. So now I'm at 0, 2. At pi over 2, I was at my max of 1, but that got shifted up 2, so that's now at 3. At pi, I was at 0, but that got shifted up 2, so that's now at 2. At 3 pi over 2, I was down at my min of negative 1, and I now got shifted up to 2, or I'm sorry, I got shifted up to positive 1, excuse me. And at 2 pi, I was at 0 for my sine value, but I now got shifted up to 2. So it's the same exact function, it's just the whole thing is moved up 2. Pretty easy. The range would now be from 1 to 3. My range would be from 1 to 3. My domain would still be all numbers, negative infinity to infinity. That's not going to change at all. This thing is going on forever in both directions. But my range would change from 1 to 3, obviously, because I shifted the whole graph up. So hopefully that makes sense. Next, we're going to talk about horizontal translations. Horizontal translations are a little bit different. We're talking about shifting the graph left and right. Now, horizontal translations are really kind of hard to see because if you think sine, remember here's sine, right? There's 1 period, there's 2 periods, there's 3 periods. I can go backwards. one period backward, another period backward, and so forth. This continues on forever and ever. So if I shift this left or right, it's almost kind of hard to see if you think about it. If you shift it left or right, you really almost don't even see the translation. I mean, you kind of do because you can think about the starting point at 0, 0, and if I move that starting point around, but the graph extends forever and ever both directions. So when you slide it, it's a little bit more difficult to see. But these translations occur inside of the function itself, inside of the function. Okay, and what we mean by that is it's going to look like this. Y equals sine of x, but inside the x is having a plus or minus c value. Okay, so it's not outside of the function. That's d that we talked about with the vertical translations. This is c. It's inside the function. Or we could do cosine of x plus or minus c. Now, the one thing you got to be careful of, it's a little bit weird here, is that if you're adding, remember, adding, you would think would move you to the right, but adding actually shifts to the left. Shifts left. So it does the opposite of what you would think. If you're subtracting, if that's a minus c, that's actually going to be a shift to the right. So that's going to shift you to the right. So it's a little bit opposite of what you normally, if you remember studying translations back in Algebra 2, you should remember that. When you're inside, you're going to do the opposite. So a plus value shifts you to the left. A minus value shifts you to the right. Okay? And like I said, again, these are kind of difficult to see. But here's an example right here. This is y equals sine of x minus pi over 2. So this is going to take my values, my entire graph, and shift it to the right. Again, it's a minus sign. You would think that would go left or minus, but it actually doesn't. It goes to the right. So this is going to shift us right pi over 2. So every value is getting shifted to the right pi over 2. So 0, again, I know it's kind of tough to see, but I'll put it in pink because I know the colors. It's blue here, but it might be kind of hard to see. There's the original period for sine, and now I'm going to shift. That entire thing is going to get shifted over. So what was 0 is now pi over 2 because it got shifted to the right pi over 2. So the entire grid gets shifted to the right. So you can kind of see that shift. So I went from the pink and I shifted it over to the blue. Now the whole graph is getting shifted, and that's why when you originally look at it, it almost doesn't necessarily look like anything changed, but it really did. If you look closely, it really does change. So the one thing I would remind you about this is when you do translations horizontally, only the x value, only the x value is affected. Okay, so shifting vertically only affects the y value. Shifting horizontally only affects the x value. So let's think about the original points. The original points for sine were 0, 0. Pi over 2, it's at 1. At pi, I was back to 0. At 3 pi over 2, I was down at -1. And at 2 pi, I was back up to 0. That's what sine normally looks like. So let's think about this translation here of shifting to the right pi over 2. So every one of these points, the x value is going to get a pi over 2 added to it. So I'm going to add pi over 2 to all the x values. So that first point that did start at 0, 0 is now going to start at pi over 2, comma 0. The y doesn't change, just the x. Pi over 2, I'm going to add pi over 2. So pi over 2 plus pi over 2 would be, let's think here, just think that through. Pi over 2 plus pi over 2 is 2 pi over 2, which is just pi. So that's now at 1. Pi plus pi over 2, so that's pi plus pi over 2, that's 1 pi, or 2 pi over 2, right? 1 pi plus pi over 2 would now be the 3 pi over 2. And that is still 0. The y's are unchanged. 3 pi over 2 plus a pi over 2 would now be 2 pi. If you need to use your calculator to do that addition, you can. Just don't plug the pi in or else it's going to be irrational. And 2 pi, so let me think this through. 2 pi plus pi over 2. Let's see, 2 pi is 4 pi over 2, right? Same thing, 2 pi. I'm just trying to get a common denominator here. So that's going to be 5 pi over 2. So that'll shift to 5 pi over 2. Right? So the whole thing is shifting over. So my period, my one cycle, is shifted over. Everything else is shifting as well behind it, which is why it actually kind of looks hard, like I talked about, hard to see the translation. But that's what's going on there. So hopefully that does make a lot of sense to you. We could also think about, again, the domain when you do this is not going to change because the domain is all angles. So if you shift, you're talking about something that's endless, left and endless to the right, and you're just moving it over, it's still going to be endless, okay? So the last thing I want to do is take a look at some examples here that kind of combine a couple of these things at once. So if I think about this function right here, that would be 1 plus cosine of x minus pi. Okay, so this is going to, the 1 is going to be a vertical shift up 1 unit, so the whole graph is going to get slid up 1 unit, and this right here is going to be a horizontal shift to the right, because it's a minus sign. You would think that would mean to the left, but that means to the right, pi units. So what I like to do is start off with my original points. Remember, cosine starts at 0 radians, it's up at 1 already. At pi over 2, it goes down to 0. At pi, it's down at negative 1. At 3 pi over 2, it's back to 0. And at 2 pi, it's back up at 1. So I'm going to draw a little picture of that so we can recall what cosine looks like. It starts up here at 1, goes down to 0, down the negative 1 to 0, back to 1. So there's our basic cosine graph, and that does repeat itself, obviously. So let's see. The first thing is all of the y's are going to go up 1. So let's think of our new points here. Our new points. All of the y's are going to go up 1. So 1 plus 1 is 2. 0 plus 1 is 1. Let's see. Negative 1 plus 1 is 0. 0 plus 1 is 1. And 1 plus 1 is 2. Okay, that was easy. So doing the vertical shift is usually really easy. Now let's talk about the horizontal shift. I'm going to add pi to all of these. So the first one's easy. I mean, 0 plus pi is pi. I mean, come on, how could you mess that up? So now I got to do pi over 2. And you might have to do some little dirty work over here. Pi over 2 plus pi. Well, pi could be looked at as 2 over 2, right? So that would be 3 pi over 2. Okay, let's see. Now I got to do pi plus pi. Oh, come on, that's easy. 2 pi, right? Pi plus pi, 2 pi. Now I got to do this other one. 3 pi over 2. I'm going to add pi. Again, pi is 2 pi over 2. That's the same thing as pi. So that'd be 5 pi over 2. And then 2 pi plus pi would now be 3 pi. Okay? So when I want to show what this new graph is going to look like, okay, first off, I have to go up to 1, 2 now, because it got shifted up. And I have to think, okay, now let me see here. Here was pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, another pi over 2, right? 5, so I got 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 3 pi, 7 pi over 2, 8 pi over 2 would be 4 pi, right? So now I'm at pi, so here's pi over 2, here's pi, I'm at 2. At 3 pi over 2, 1 pi over 2, 2 pi over 2, 3 pi over 2, I'm at 1. At 2 pi, I'm at 0. At 3 pi over 2, I'm sorry, that's a 5 pi over 2, I'm at 1. And at 3 pi, I'm up at 2. So here's my graph here. So notice, looking back up to this original, the whole thing got shifted, and it's not a very nicely drawn curve, but it got shifted up, and it also got slid over. Now, don't forget that all the other parts got shifted as well. So all the other parts are shifted as well, but that's the main middle cycle. I mean, the main cycle, the first cycle that gets shifted. So I don't want to spend a ton of more time having you watch this video and see these examples, but this is an example that would combine everything. Hopefully you understand the idea of shifting right and left and up and down and how those values are going to affect the actual picture of the graph. And we're going to do some more practice with this in class as well.